So I'm here to talk a bit about how to create internal developer platforms, and more importantly, that to create a great internal developer platform, it's going to start with your API. And that's because internal developer platforms are just a piece of software. And my experience is that great software starts, feel free, come on. Seriously, not worried. Great software all starts with an API. You may not sell your API. The API might not be how your users think about your software, but because they may have a fantastic user interface through a web browser or something else. But great software has a great API that gives data in a way that can create those experiences on the user interface. And internal developer platforms have user experiences and multiple user interfaces, so they need an API on them. So if you've been paying attention to the industry, you may get a little bit confused about this narrative. So you say, hey Abby, if the API is so key, why is everyone talking about portals? Oh, sorry. Why is everyone talking about portals? Because that is what you're seeing in all the conversations around developer platform engineering. Oh, there's the mic. Well, I have a loud enough voice. I'm not sure that's helpful. Thank you. So if APIs, if I'm making the argument that behind every great piece of software is an API, and internal developer platforms are a piece of software, and so they need an API, why is all of the conversation in platform engineering around portals? And you can take that as a bit of a hot take, a bit of a dig at portals, but that's not what it is. I think portals are great. I think very likely you might benefit from a portal. And it may even be the thing that your company is missing, and the next thing you should do at your company is create one. But a portal alone does not make a platform. A portal alone is just another user interface into the offering that is your platform. And you can read about what those platforms can offer. These are 3 portal examples on the market today, some open source, some not, some commercial, some not. And you can see that with a portal, you can get your arms around what software you have, you can see what your team owns, worry about the sprawl. You can get your docs written in code next to what you're working on. You can use gamification to create scorecards and have people kind of improve their use of the platform. This is all true. But that's all business logic to your platform. And we've all built software in the past and learned that we shouldn't put business logic in the UI. Business logic that you might have in your platform is around how you customize things. How much are you reusing what's given to you as a SaaS provider? And how much do you need to make sure is done for your business? For example, every database created needs encryption. That's part of your business logic. You need to look at how you deploy and schedule things. This is part of your business logic. If you want something to be reliable, you may go across regions or even cloud providers. How you do that is part of your business logic. Creating on-demand infrastructure. What does a test environment look like? What size is it? What does it look like? And how do you get one? That's part of your business logic of creating a platform. And that shouldn't live in the UI. Speaking of UIs, have you ever found an organization where everyone wants the same UI? It's not going to happen, especially if you're a platform that's servicing more diverse users than just software engineers at a certain level. And even if you are only servicing software engineers of a certain shape and size and type, realistically, they may want to use some of these capabilities in a CI pipeline. All of a sudden, a CLI tool is important. What happens when all of your business logic is in a portal? So chatbots, ticketing systems like Jira, CLIs, those are examples of UIs or user interfaces like a portal that you may want your platform to be able to speak to. So portals are just another UI. So if you're focusing on trying to deliver a platform, focus on your API. That portal will come with it naturally, and you'll create that user experience based on the needs of your users. So when I say API, application programming interface, it's about having multiple consumer applications be able to speak to a single location for its business logic to answer questions. What that comes with it is in the name and interface. So now you have this contract, which unleashes both sides of the contract, both the consumers and the producers, to be able to make decisions and build independently of the other side. Building is an experience. How you shape that data changes what types of user interfaces you can use. If you've ever built off an API, you've probably had the same experience as me, where you've gone, oh, I really want this to look like this, but that data shape is making it really hard, and you either have to do a lot of heavy lifting, or you just give up and do it a different way. So how you shape that data in your API means something, and it builds an experience for the users. And part of that ability to separate and allow the two sides to have a contract to work with is that you can version it. Semantic versioning or something of the sort, which allows you to indicate when there'll be a breaking change versus when it's a new feature or just a small little add-on that no one will really notice, gives people the ability to take on those new features when they're ready and gives the producers the ability to continue to evolve without worrying about backwards compatibility at all times, as long as you're aware with your versioning. So you might be saying, still, but Abby, this is boring. I already do this. I do this with code. That code might be Terraform modules, Ansible playbooks, Helm charts, CloudFormation templates, whatever it might be. Because you have an interface. Terraform modules, what you expose in a Terraform module is an interface. They design the experience of somebody using that template. They design what they can change, what they can alter. And as you can see in this image from a Gruntworks blog, you can version it. So people can choose to take on the changes as they need to from that code. So it looks like an API, I agree. But it's not an API. And what I've been trying to figure out a way to describe this, because people get very attached to their templates, and what I've come to is the shared responsibility model, which is something that I have experience with as a consumer of the cloud APIs, as a consumer of AWS and GCP. With the shared responsibility model, there is a discussion that says, we are in charge of certain things and you're in charge of other things. And this is particularly true when it comes to security with cloud offerings. So who's in charge of securing the server you spun up in AWS? Well, there's different ways. Physical security is AWS's job. It's in their data centers. But patching security is on your job because you own this server. It's yours. That's what a shared responsibility model looks like. So I took a stab, first draft, please come tell me why it's wrong, of creating one that may start to form something you could do with an internal platform team to the consumers of that platform, your application developers. In the column on the left, you've got the design infrastructure as code, actually creating that code. Then you have to create the infrastructure using that code. You have to keep that code up to date and extend it. You have to manage the infrastructure that's running if it has incidents or patching and those kinds of things. And you have to actually use the infrastructure. We're not just creating infra for fun. Across the top, I've got the different models. And the first two, dev and ops and DevOps, you probably will kind of be able to guess where I put our little ops, DevOps, SRE platform. I refuse to take a side on all that, as orange and application teams as purple. So in my experience, when you have a dev separate from an ops team world, you have the ops team or platform team or SRE team managing all of those first set of things. Designing the code, running the code, patching the code, dealing with the infrastructure. And what that results in is a shared ownership when it comes to configuring the infra. Yes, in an ideal world, you'd be able to say, application teams, I made your database, now go use it. But the reality is that the ops team understands everything deeply about that. So whenever you run into a real problem around something like performance or reliability, it becomes a collaboration because the reality is the team doesn't know how to manage that stuff. DevOps world, super easy. Application team manages everything. That doesn't mean it's a JavaScript dev managing your entire infrastructure stack, maybe, but it does mean that because there could be a specialist inside the team. But it means that within that team, they have to design the code, create the infrastructure, patch that infrastructure, run it, and then get to the business value that is actually configuring their app to use it. Which is why we've evolved in many places, and I have been a huge proponent of platform offering code templates in the past, to create this. And so what you do is you say, hey, you shouldn't have to think about what the infrastructure looks like. We can do that for you. We have Terraform experts. We can create that business logic of what a database looks like at this company and give it to you. And then you can go off and you can run that in your AWS account that we give you access to, your GCP account. And now you can create your infrastructure without the bounds of having to open a ticket for us. And that's great, till you have to update it. Then what happens? Well, depends. Are you updating the template? Okay, that's probably still owned by ops, but there's no real push of that use of that template. So then all of a sudden the application teams need to actually get that up to date. And that's natural when you talk about platform as a product, just like we heard about in the last talk. Like, there's going to be changes that need to get pushed out, introduce a new API version, and there needs to be that collaboration. The problem is when it comes to like a security patch or something behind the scenes that actually the application teams never knew existed, don't care about in any way, but is absolutely critical to your organization to get it out. Now you need this kind of collaboration to get anything like that out into your environments. When it comes to actually managing the running infra, just put a grimace face. I don't even know in this. Like, in my experience, if you're using templates that other people are running in their AWS accounts or in their Kubernetes clusters or everywhere else, like, they don't really know what they're running. They used your template. But like, all of a sudden, it's having issues, and now they need help. And so who does own that? The people who wrote the code to create it, or the people who ran the code to create it? Probably depends on your culture, right? That's why I didn't take a stand. And we're in the same place as with dev and ops. When you configure the app to use it, you often need a lot of collaboration because they weren't deeply involved in the creation of the infra. When you get to an API, you're setting that barrier. And this is idealistic. You can call me out on that in all ways. That's fine. But you're setting, the point of an API is you are defining what the application teams need to know about and what they can configure, and making sure that they're unblocked to be able to be effective. And so you are the best APIs draw a strong line between writing the code, running the infrastructure as code, keeping it up to date, managing the infra, and how it gets used. That is basically the test of how effective your API is. Can the things you're exposing and the things you're asking your application teams to own, can they actually do that? Depends on how great your API is. What are you telling them about? What are you keeping behind the scenes that they don't have to worry about? So that's why I think an API matters. And the problem is that today, when building platforms, our current tooling draws us into these false dilemmas. It tells us that if we need to have a high level of business customization, we need to have a hands-on approach. So we need to use things like ticketing systems and Slack to be able to have conversations and make sure that we are building in exactly the way the business wants it to. It's telling us that if we want the devs to be able to move fast and add new capabilities, that we need to just give out AWS keys and Kubernetes clusters to anyone and let them just run wild, where we can't keep track of what's going on and make sure it's secure. It tells us that if we need access to new things, we have to template, because if they've got this access to the cloud, well, they don't really know how to write the Terraform or the CloudFormation or click around on the UI. Let's help them get there faster. And it tells us that if we want to use an extensible API, something like Kubernetes is a fast way to go. But Kubernetes isn't right for everyone. Some is functional functions as a service or other things. That's not, as said in the last talk, Kubernetes is not the same as a platform. It's a part of the platform. And so what I sort of encourage is this idea of shifting the focus from tech to product. We want to build platform as a product. And so we want to focus on the intentions of what we want to deliver more so than the implementations or the code behind that. We want to make sure that we're customizing to the right level of the organization, that we're keeping our abstractions at a high business level, and making sure that that can absorb as new tech comes on board and can take some of our heavy lifting away. Let's use that, right? We want to provide an on-demand and self-service option through the right clients for the right users. And we want it to be widely used, we want it to be consistent, and we want it to be extensible. What I mean by that is when somebody gets used to using your platform to do one thing, it should seem kind of obvious how to do another thing and another thing. And as they build up the muscle of how the platform works, how the CLI tool works, those kinds of things, they should be able to intuitively understand where to go next for the next thing they need from their platform. And so, platform as a product, and it's got to be coming from the API. And the benefits of getting this API in front of that platform is from the consumer side, you get the same thing we talked about for the portals. You get that catalog of offerings, you get that on-demand, even if not instant, delivery of things. This is like when you go and buy an airline ticket, and they say, oh, we'll email you your confirmation when it's ready, right? Like, API doesn't have to be synchronous. It doesn't have to be instant. But as a consumer, you also now all of a sudden get access to more than one interface if you need. And you actually have the ability to create your own interfaces. You might want to create your own CLI tool if the platform team hasn't had the time to create one yet, right? So this is unleashing you as a consumer. As a provider, it separates the implementation from the behavior. All of a sudden, when you want to move cloud providers, no one else needs to know. When you want to change from a different database type, no one needs to know. What they need to know is what is exposed from the API. Also, APIs can be evolutionary, both in the sense that you can introduce one endpoint and then another endpoint and another endpoint, but you can also introduce an endpoint that is extremely asynchronous, that might take a long time to reply back, and you get through a Slack message or an email or something, and then speed that up as and when the business needs it. And it allows you to manage that business logic in a single location, in a testable location, hopefully. And so when that business logic changes, you're not jumping around into all your user behaviors and trying to change it all in a row. So when we shift our focus from tech to product, we end up providing an experience as a platform team. And to do that, we can start with API-driven, right? So this is the first part of your API. If you want to take that first step towards a platform, it doesn't need to be building an API, sitting down, writing code. It's about having a conversation with your users about what it is you need. And then you can go back and worry about building the thing that actually supports that API, the actual implementation of it. So start by the design. Start by what is it that your users care about? What is it that you as your business stakeholders care about? And how do you want to manage that? For example, is like test environment as a service. You may want to expose things like time to live. How long do they want the environment to live for? There might be sensible defaults there, a day, a week, whatever it is your organization stands by. There may even be maximums, a week maximum, to try and encourage faster merging into main and things like that. But you want to expose that because there's different use cases. You want to expose where to deploy the code from, how to update that code based on, is it continuous deployment or is it something else? But there's also things you don't want to ask about. You want to hide things like size of database because no one actually cares about that in a test environment, but the business cares that it's cost effective. So that's your business logic into your platform. Region it's stored in, no one really cares, but your data residency might care. And so things like that you own as a part of the platform. As I said, API-driven development doesn't mean you start with code. It starts with the conversation. But even the implementation doesn't have to start with code. You can meet your users where they are. You can say, right now, someone goes in and requests a database through Jira. Why don't I use Jira to help define a more clear API with my users, which can drive the call to my backend API, which then I can decouple Jira and create new user interfaces if we want. So here comes internet. What I've got here, live demos, is on the left here. We've got a Kubernetes cluster. It doesn't need to be quite that large, I don't think. Kubernetes cluster that's running a platform tool called, or platform framework called Kradix. What we've got installed here is some promises. One in specific, which provides access to an AWS database. I know you don't know what any of these words mean yet, doesn't matter. We have an API that offers AWS databases. That's what actually matters. Now, how do we actually allow requests to that API? We do that through a Jira ticket. I have an issue type of database. In it, I have a summary. Customers, I think I already have one of those. It's cool. We'll make another customer database. I then have some set databases I can offer. Let's say for my customer database, I want to use Postgres. Now, as a platform, and I have a team name. What's a good team name? I go with animals, tigers. These are required fields. We have optional fields, things like that. Now, as a platform provider, I haven't yet actually implemented the automation behind a Postgres database. So when someone creates that, what's going to happen is in my platform, which is the backend here in Kubernetes, I can go see that I have created a new database request with some names from Jira to make it easier to see. That's just the business logic of the platform. I can see that resource request has been now requested as a status. And if I switch tabs here to Slack, I can see that I've just had a new request come into my Slack channel. Because actually, all I've implemented at this point from a platform point of view is that I want my platform team to be aware a request came in quickly. I haven't actually done the automation. It still takes manual effort for me to create this Postgres database. But in contrast, there's nothing stopping me from creating another when someone creates another type of database, addresses, and them to want a DynamoDB database, much faster to come up. And these are my old stuffed animals, pandas and tigers. And when they create that, we see another database request come into our platform, and it's pending. And we have some business logic that runs there. And we can see that business logic running in a pod called a request pipeline. Is it that one? We'll find out. Nope, not that one. That one. And we've got Terraform now running, because that's the way I've chosen to automate it as a platform team, to create a request for a DynamoDB. And it has all sorts of logic in there around what the database should look like and all those things. And it takes a minute or two, and eventually we will see the logs go and the DynamoDB show up. If it doesn't, you can see it's kind of coming. And so what this is allowing me to do is take that first step towards creating an API without having to worry about what does a web UI look like, what does my portal look like, make all those decisions about user experience, and potentially have to change the user behavior of tens, hundreds of thousands in some companies of developers and users. Meet them where their user experience is, but unleash yourself as a platform team. Think conference Wi-Fi may make installing Terraform plugins slow. I'll come back to this and show it. The cake. So that is an example of what you can do with an API and how you can get started really quickly using Jira. How did I do that? Yes, this is where I talk about the thing on my shirt. Cradix. What we've found through years of building platforms, the team I'm on, is that there's a lot of boilerplate, there's a lot of glue work to making these things work. And people right now in the industry are basically selling you either buy your platform or start with Golang and Bash and super bare minimums. That's your option. Buy, build. And I don't think that that's the right way to look at it. I think we should be buying a lot of our platform. We should be using cloud providers where we can. We should be using portals where we can pay for them. Things that are non-differentiating, we should be buying. That's 80, 90% of the thing that your platform team should be offering. But there is that business logic. There is that customization you need to own. And so what Cradix does is it creates a framework for you to create a promise of what you offer to your users. That promise has the ability to have an interface, as what we call an exit service CRD, that creates that interface with those requirements. It allows you to manage the infrastructure deployment and the scheduling of it. Because, so you can think about Cradix a bit like you might look at Rails to Ruby. You get Rails and it doesn't give you a web app, but it gives you the abstractions you need to get your web app up and running fast, the things you actually care about. And that's because there's actually a lot of complex business domain in platforms. From the user interface point of view, you have to think about what options you want to provide and validations of it. From the business logic point of view, you have a whole bunch of security requirements and configurations, FinOps, all these things you have to worry about. And when it comes to provisioning, you have to have awareness over what you actually have in your infrastructure fleet. Is it on-prem? Is it cloud? How are you being cost effective with the decisions of where you deploy things? And this is the complex domain that we as platform engineers need to deal with. So can we help take some of that weight off and allow you to think about the business side of that rather than the glue side? Cradix Promise does that by providing Kubernetes custom resource type that allows you to codify these pieces and then evolve them as your platform evolves. And I know that text is small. Again, this isn't about getting the code written. It's about getting that conversation over what is a platform API and what do we want to be building with it. So with promises, you can compose larger promises. When we think about things, you want to provide a database independently, but you also probably want to provide a test environment that relies on a database. This is now all of a sudden becomes puzzle pieces. When you codify and group them up into something like a promise, you can create a larger instance. So with the API, the framework that Cradix provides, it allows you to create a simple API. You can write your first promise in minutes, but it can get complex fast. So it gives you the building blocks to actually handle those complexities as you grow. That's the vision for it. We are a free and open source tool that's Apache 2 licensed and early days. So looking for a lot of feedback and a lot of interaction with people as they use it. But this is the vision that is being built because there isn't something on the market right now that helps you go decide between build and buy. It's really quite difficult right now to start from scratch. So platforms are just software. Treat them like that. Don't put your business logic in the UI. Communication needs to start manual. That is what communication is. But then you can automate it as you understand your users better. Create an API that is extensible and evolutionary. And it can feel absolutely oppressive when you're on a platform team, the amount of toil you have. I have been a platform engineer for many years, just stopped about a year ago to build this product, and I definitely know what it feels like to say, I'd love to, that sounds great, but when will I have time? So figure out how you can build into your current processes a stopgap, because every minute you save, every little bit of optimization you put in, you build an extra minute to spend on that new way of working and start to build yourself some time. So the big thing is evolution is more practical. And yes, you want to create a revolution, but you have to start with baby steps and figure out ways to start with those baby steps by leaning on community, leaning on what's out there. I think that's my last slide. So let's see if we have a database. Hey, we have a database. Yeah, and like things that have been in there. Sorry, this is terribly zoomed in. Let's see, I can squish that now. That I've been able to put in here now is things like tags. So I was able to track who made that request. I didn't write Abby Bangser anywhere, but I'm a user in Jira, so I can steal that. And I can send that to my API, I can then have that there. So this is where you start to build your business logic about what it is that you want to manage. And if I'm right, thank you.